Hello, am I audible and is my screen visible? Yeah, all right. So, hi everyone, my name is Anton, and today we'll be going through a pretty common type of algorithm that you will be encountering throughout your journey, and those are called greedy algorithms. So, yeah, let's get started. So today's topics are we'll discuss what is the greedy approach, and we look at some examples. There's not a lot of theory there, so we'll be going through more examples rather. And finally, we'll go through the limitations of the greedy approach. So, yeah, let's kind of start. So, what is the greedy approach? So, throughout your journey, you'll come across certain problems that require you to maximize or minimize a given metric, so or a score. In such cases, your program or your algorithm needs to make some choices. So now greedy algorithm comes in such kind of problems, and it works upon the idea that making the best choice available at each state will hopefully lead us to the globally optimal solution. So the globally optimal solution is what we want, and the greedy algorithm we hope that it will lead us to the solution. And I'm mentioning hopefully because again I'll come back to it during the limitation section. But for now, let's see how a general greedy approach will look like. So you start with the initial state, and from there you look at all the available choices, right? So at each point, you would have to pick the choice that seems best at that particular moment. So the greedy approach doesn't care about what comes later or what has come before. You choose the best option at that moment, and you go to this new state and you repeat the process until you have reached the end of your states. So we look at an example of how you would this works. So let's look at this. There are n students numbered from 1 to n, and each student has a level associated with him or her, and that is denoted by in the array ai. So there are n numbers, and each number is the level of the student. So now your task is to split the students into stable groups. And what are stable groups? A group of students is called stable if in the sorted array of their levels, no two neighboring elements differ by more than a given value x. So, for example, say that x equals 4, and you're given this array 1, 2, 5, 7, and 8. So you can see that this is a stable group because the difference between 1 and 2 is 1, 2 and 5 is 3, 5 and 7 is 2, and 7 and 8 is 1. So at no point is the difference more than 4. However, this case, this is not a stable group. So this is 1, 2, 7, 8. So as you can see, the difference between 2, 7 is 5. So this is not a stable group. So now your task is to find the minimum number of stable groups that you can form. So each student will go into one maximum of one group, and you need to split them such that all the groups are stable. So you need to find the minimum number of stable groups. So what are the states and what are the choices here? When considering each student, we have two choices. We can take him or her in the current group. So let's say we are building a group, and if we encounter a student, so our choice is we can either take him in the current group, or we can start a new group. We can start a new group with that particular student. So now, as the task here is to minimize the number of groups, we have to maximize the number of students in each group. So I hope the question is clear as until now. So I want you guys to scan this QR code, and this will lead to the Slido link. So and this will lead to a quiz where you would have to come up with, you would have to find the number of stable groups that has to be formed with a given array. So I'll give you guys about so now it should be live. You can see the question. Yeah, this is. I'll give you guys a couple of minutes. Just look at. You're given an array and you have to find the minimum number of stable groups that can be formed with it. So try coming up. Just use a pen and paper or use your mind and just find out what would be the minimum number of stable groups that you can form. Yes, you can start. You can start putting your answers in. You guys have time. You guys have 30 more seconds. Try to finish it off. Okay, if you guys didn't know, a stable group is such that in the sorted array, no two neighboring elements should differ more than x by more than x. So yeah, your task is to find the number of stable groups. You guys, I'll give you guys some more time if you guys didn't know what a stable group is. So I guess I'll stop the quiz for, I guess all of you have responded. So let's see the results. So 41% of you are given the answer, and that is you can form two groups. So what would it be like? So let's see. 2, 6. Sorry. So In this case, there are just two groups, and I'll come to the solution right now. So a solution would look something like this. We have to maximize the number of students in each group. Therefore, we have to group students with closer levels. So we can do that first by sorting the students in the order of increasing level. So you guys would have learned sorting the previous class. We can use the inbuilt function to sort the array. And now we'll go through each element, and if at any point the difference in level between two adjacent students is greater than x. So in that case, we would have to create a new group because there's no way we can not we can accommodate that person in the current group because the difference in level is greater than x. So look at this example: 1, 2, 4, 5, 8, 9. This is already sorted, but and let's say x equals 2. So now, according to this approach, that we look at each successive element and we split at points where the difference is greater than x. So look at this. The difference is 1, 2, and 1 again. But between 5 and 8, the difference is 3. So there's no option, but we'll have to may start making a new group. So according to a greedy approach, we'll get these two groups. So even in the quiz that we saw right now, you can do the same thing, and you can find out that there'll be two groups. So think about why it works. Again, we have to group students with closer levels so that you can apply the greedy algorithm. If it's not sorted, and we sort so that the students are grouped with closer levels. So I guess everything is clear. Can you guys respond if everything is clear? If you sort, you're not changing the neighbors. Yeah, the order of students doesn't matter. Anyways, they have asked in the sorted array of their levels, no two neighboring elements should differ by more than x. So the order of the student doesn't matter. We just want the difference between two neighboring elements should not be more than x. Hope that answers your question. So I guess I'll continue. So if you can, this will be the code for it. So I'll explain the code. This is this is just the main function. You get n and x as input, and the vector of the array, elements of the array. So this is just standard. And now you'll sort the whole array in increasing order. And this is the part where we apply the algorithm. So the number of groups is 1, and we'll go through each element. So we'll start with I equals 1, and we'll go until I is lesser than n. So that means you'll go until I equals n minus 1, which will be the last element in the array A. And we check if A of I minus A of I minus 1. That means the difference between the current element and the previous element. If that is greater than x, that means you have to increase the number of groups. So you do that throughout the array, and once you reach the end of the array, you can exit the loop and you print the number of groups. So I guess that's clear. Can you? I'll stay in this for a couple more seconds. You can try to understand what is it about. Yeah, all right. I guess we can continue. So now that we've looked at a common example, we'll now look at the limitations of the greedy approach. So it doesn't always work. That's because it can only be applied to a limited set of type of problems. So you can't apply the greedy algorithm to all the problems that you see in code forces. This is because the solution obtained by greedy algorithm may not be the best solution. So the problem will obviously ask you the best solution, but If you're doing the greedy approach, you're choosing the best at each state, not the globally optimal solution. So sometimes you might not get the intended solution. So we look at one example where uh, greedy approach fails. So now we'll just to say whether a problem can be solved by greedy approach, you can try coming up with counter examples where the greedy algorithm fails. So let's say you're given a problem and obviously there'll be test cases given. So if you're unsure of whether you can apply the greedy algorithm or not, you can try coming up with your own test cases and apply your greedy algorithm on that. And if it doesn't work, then even if there's one test case where the greedy approach fails, then it means that the problem can't be solved with that approach because, as you know, your approach has to be the has to be general. It has to work for all possible test cases. If it works for, even if it doesn't work for one, that means you can't apply the greedy approach. So right now we'll look at one example. So yeah, consider that you have infinitely many coins with given denominations in the array D. Now we need to find the minimum number of coins needed to make a given value V. So let's say you have infinitely many coins, 1, 5, 10, and 25. And you are asked to use these coins to make the value of 30. So you need to find the minimum number of coins, mind you. So now think whether you can take a greedy approach to this problem and also try coming up with other test cases. I'll give you guys 30 seconds or something. Think of what approach you can take. All right. So I hope you guys have found something. So even if not, we'll look at possible solutions. So for this given example, 1, 5, 10, 25, and for the value of 30. So one might say that we'll take this greedy approach where at each point we'll greedily choose the highest value coin that we can take. So take because you're trying to minimize the number of coins, it would be beneficial for you to maximize the value of the coins. So this is a greedy approach where you just choose the highest value coin that you can take at that state. So in this case, you look at the array and you have to find the value 30. So what is the highest value that you can choose from these? Obviously, you can choose 25 because 25 is less than 30 and it's the greatest among these. So you will choose 25. And now you have remaining of, you need 5 more coins. So obviously you can't choose 10 and 25 anymore. So you'll only consider the coins 1 and 5. So even at this point, you would choose the highest coin. You'll choose 5 to get 25 comma 5. And this is indeed the correct answer. So if you think there's no other way you can get it with one coin, so the minimum number of coins needed is 2, 25 and 5. However, it doesn't mean that the greedy approach is entirely correct. So this is just one test case, and in this case, the greedy approach is correct. However, that doesn't mean it's correct for the whole sample, whole possible question. So, for example, try coming up with counter examples where the greedy approach might fail. I'll give you guys a minute. So, yeah. Yeah, I want you guys to scan this QR code. So in that, there'll be multiple choice question where select the you can select the examples where the greedy approach might fail. So yeah, I want you guys to scan this QR code. And you can respond to the multiple choice poll that's there. Keep in mind, you have to find the cases where this greedy approach that we discussed would fail. So we discussed that we'll just choose the highest value coin. You need to you need to see if there are test cases in those options which would not work with the given approach. And also remember that there are infinitely many coins in each uh, in the given denominations. I'll give you guys 30 more seconds. All right. I hope you guys have finished responding. Yeah, almost all of you have. So majority of you are wrong. You would so look. So let's discuss it. 137 and value of 20. So obviously you can choose two coins of 7 and two coins of 3, and that in that case, oh yeah, in that case you'll be able to see that you'll choose two 7 coins. So you'd get 14 and you need remaining of 6 coins. So obviously you can't choose another 7. So you would choose 3. You need 3 more coins. You'll again choose 3. So in that case, the greedy approach works. However, if you look at option B and C, you can't, uh, that wouldn't work. So yeah, I'll end the poll and we'll discuss how this would we'll discuss with one example. This is the option B that you would have seen. So given that it's 1, 2, 5, 7, 9, and V is 12. So according to the greedy approach that we discussed, we would first choose 9 and we'll have a remaining of 3 coins. And now for the remaining 3, you would choose 2 and then a 1. So you'd get 9, 2, 1, and that is 3 coins. However, if you notice carefully, we could have picked 7 and 5. So we didn't these two coins, which is just 2 coins, yeah. So obviously this is a classic example where the greedy approach fails. You can't just blindly assume that it would work, and so this is the importance of coming up with more test cases. So similarly, even option C would have is almost similar to this. So I hope you guys understood. There's no intuitive way where you can tell your algorithm to choose 7 and 5. You can easily come up with more test cases where we can't apply the greedy algorithm. So this is a very big limitation of the greedy approach. That is, you can't cover all possible cases. You're just choosing the best option at that point and you're hoping that would be the best. So in such cases and in a lot of problems, you might not be able to apply the greedy approach. So you have to remember that. So then so some of you might wonder, how do you actually solve this problem? So this requires a more advanced topic known as dynamic programming. We'll not be going into that for now because it's a bit more advanced. However, you can keep that in mind. You can search up on it if you want. But yeah, in this case, you can't apply the greedy approach. So I hope that's clear. So yeah, all right. Okay, so you guys want me to... Okay, I'll repeat this once more. So look at this. You need a value of 12 and you have infinitely many coins of 1, 2, 5, 7, and 9. And the greedy approach we discussed was we'll greedily choose the highest value coin that we can take. So in this case, we would choose 25 and 5 for value 30. But look at this case, 1, 2, 5, 7, and 9. If you use the greedy algorithm, you would choose 9 first because that is the highest coin that you can take. And later, now you need just 3 more coins. So obviously you can't pick 5, 7, and 9. So your choices are limited to 1 and 2. Out of these, 2 is greater, so you'll pick 2, and you need one more coin, and therefore you just pick 1. So 9 comma 2 comma 1. The sum of it is which is 12, and this is 3 coins. So we get this by using the greedy approach of choosing the highest value coin. Again, but if you notice carefully, we could have picked 7 and 5, which just 2 coins, and 7 plus 5 is 12. So you can see why the greedy approach fails, because we didn't even consider choosing 7, and therefore we didn't consider choosing 5 as well. So there's no simple way to tell your algorithm that, okay, I want you to do this. So that's why the greedy approach fails. I hope that's clear. Hmm. Option C. So 1, 2, 3. If you guys looked at the multiple choice question, 1, 2, 3, 5, and 6, and you need a value of 10. So using the greedy approach, what you would do is you would choose 6, and you need remaining 4 coins. And yeah, and then you need remaining 4 coins, and your choices are 1, 2, and 3. So now you will choose the coin 3, and then you would choose coin 1. So that is 6 comma 3 comma 1. However, you could have chosen 5 comma 5. That is just 2 coins if you notice. And as I mentioned, there are infinitely many of each coins. So you could have picked 5 comma 5. So that is pretty much similar to this case. So which that is why that particular case fails in the greedy approach. So yeah, I hope that's clear. All right. And I hope you can continue. And as I mentioned, solving this requires a more advanced topic called as dynamic programming. You can search up on that later if you're curious. But for now, let's look at a few more examples where you can indeed apply the greedy algorithm. So this is a code forces problem. So let's see. You need not go to the link. The question is here, and you need not code it right now. We'll just discuss the solution. So you're given two arrays, A1, A2, until AN, and B1, B2 until BN. So these are two arrays of length n. So you're given these two arrays, and in one operation, you can choose any integer I from 1 to n. So that would be your index, and you can swap the numbers ai and bi. Swapping is just if it's 2 comma 3 and you swap it, it'll become 3 comma 2. So that's simple. So now you have to determine whether using any number of operations. So this is one operation. You need to use any number of these operations to satisfy these two conditions simultaneously. That is, both of these conditions should match. And what are these conditions? Let's have a look at it. an. So an is the last element in array A. So an should be equal to max of a1 comma a2 until an, and bn, which is last element in the array B, should be the maximum element among all the elements of B. So again, you can see that maximum of a bunch of numbers denotes the maximum number among those numbers. So for example, max of 3 comma 5 comma 4 will be 5, and maximum of 1 comma 7 comma 7 is 7, and the maximum of 6 comma 2 would be 6. So you need to use these operations to find out whether you can satisfy these conditions. An has to be the last element in A has to be the maximum element in A, and the last element in B has to be the maximum element in B. So yeah, I hope the question is clear. You guys can take a couple of minutes and come up with a solution. All right. So I hope you guys have come up with a solution, or at least try to come up with test cases where you can apply an approach. So yeah, I'll discuss the solution for now. So this is just one solution. If you come up with other solutions, that's well and good. So yeah, let's get into it. So first we'll define M to be the maximum element in both A and B. So you'll just simply go through all elements in A and B, and we'll find the maximum element among both these arrays. So now we can have a solution if and only if either an or bn is equals to m. So what this means is that you want either the last element in A or the last element in B has to be equals to m. If it is not, say m is somewhere in between, then that means whatever we swap, we won't be able to satisfy that condition. So because say there are 5 elements, and in the third index you have the highest element. So obviously at the last it'll be lesser than uh, that particular number, capital M. So we don't want that. So for we'll preliminarily check whether the last element is equals to M. If it is not, we just say there's no solution possible. And now like to actually solve to make the greedy approach, we look at each I. That'll be your state. And in each state you can make this choice. Keep it as AI comma BI. That is, we don't swap, or else we can swap it to get BI comma AI. So yeah. So if you this is what these are your choices that you can take. So now the greedy approach would something like this. You would swap such that the greater element is always in the second array. And by second array, I mean array B. That is, if AI is greater than BI, then we will swap, else we'll just keep it as it is. So again, think about why it works. Mm, we know that regardless of the elements in B, all elements in B will be lesser than the last element in B, which should be equals to M. So because AN and BN, one of them is equals to M. And according to this approach, you will just end up with the last element in B equals to capital M. So that means whatever elements you have in B, B1, B2, B3, up until Bn minus 1, all of these elements will definitely be lesser than Bn, which is the maximum element across both arrays. So now that you know that, this is almost intuition that you can say that the best way of swapping is that we put the larger numbers in B because we know that B will satisfy the condition. So we put all the larger numbers in B, and then the smaller numbers will be in A. And then we'll check array A if it satisfies the condition. So that'll if that satisfies, yes, both the arrays satisfy the condition simultaneously. If A doesn't, you can't do anything other than that. So the answer will be no. So I hope that is clear. We look at the code for it. So this is just a snippet. I've left the input part of in getting the input A and B because I guess that's pretty straightforward. You guys would be pretty comfortable with it by now. And also finding capital M. That is simple. You just go through all elements in A and you find M, and then you go through all elements in B and then you update M. So now this is where the greedy approach comes into play. So now you check if the last element is not equals to M and the last element in B is also not equals to M. In these cases, that means the largest element is not in at the end. So these cases you can't do anything. You have to print no and continue with the next test case. So if you guys didn't know what continue is, continue would, if you have a loop and you have continue, uh, when control encounters continue, you will just stop executing any future statements and will just continue with the loop. So as it suggests. So I hope that is clear. Now this is where we apply the approach. We'll go through all elements in A and B, and we'll say if AI is greater than BI, if the element in A is greater than B, we'll swap it. So at the end of it, you'll get your array such that the larger elements are in B and the smaller elements are in A. So now that you're done with it, you can be assured that array B will always satisfy this condition because the last element in B will be capital M. So now you will have to check for array A. So I'll define a Boolean value OK, and OK denotes whether A satisfies the condition or not. By default, it's true because we are assuming it satisfies, and we'll go through each element in A. So for int I equals 0, I less than n minus 1. I've put less than n minus 1 because we don't want to check. We obviously don't want to check the last element, and we are also yeah. So we don't want to check for the last element. So we'll do this. If AI is greater than a of n minus 1, that is, So let's say I equals 0 and I is lesser than n minus 1. So yeah, and a of 0 is greater than a of n minus 1. If that is true, that means the first element in A is greater than the last element in A. So this is the case where your condition breaks. So obviously, that this means that whatever you do, you can't proceed because uh, it's wrong anyways. So we'll just say OK equals false and we'll break. So if you guys didn't know what break is, so break is almost the opposite of continue. So there's this for loop, and when it encounters break, it'll just stop with the for loop and it'll just come out of it. So we are coming out of the for loop because we know that once there is even one element that's greater than the last element in A, then the condition is broken. So we'll just exit the loop, and this is where we'll check. Okay, if the OK value is still true, that means yes, A satisfies the condition. Else we'll print no. So that will be the case where there's one element which is greater than the last element in A. So look, I hope everything is clear. You can look at the code for, I'll give you some time, and you can ask any doubts that you have. I'll give you guys 30 more seconds or something. Could you explain what you're doing after swapping? So yeah, so now that you're done with swapping, you'll the larger elements are in B and the smaller elements are in A. So we know that array B will satisfy this condition. And the condition is that the last element in B has to be the maximum among the elements in B. So array B will satisfy the condition. So now we are checking array A. So this is where you'll check if this element in A is greater than the last element in A. So you know A of n minus 1 will be the last element in A, and A of I will be A of 0, A of 1, A of 2, and so on until the second last element. We obviously don't want to compare the last element with itself. So if that's the case, we'll just say, yeah, uh, you can't satisfy this condition, so you'll break out of it. So I hope that answers your question. This is where we are. So basically, this is where we are checking that even array A satisfies the condition. We know that array B satisfies. This is where we'll check whether array A satisfies the condition. And if it does, we'll print yes, or else we'll print no. So I hope that's clear. So yeah, you guys can scan the attendance form. I'll give you guys a couple of minutes. I hope it's visible. So, yeah, all right. I hope all of you have filled the attendance form. Don't worry, the attendance form will be shown at the end of the session as well. So, for now, we've reached the conclusion of the session. So, as you might have noticed, greedy approaches are closely related to your intuition. You, it's like when you're given a problem, the greedy approach might would be the first thing that you think of. So, it's closely related to intuition. So whenever you come up with a problem, you need to come up with test cases to find out whether the greedy algorithm will work. So obviously it'll fail even if there's one test case. If it doesn't work, then that means the greedy algorithm fails. However, if you're not able to come up with a counterexample, then you can, during a contest, you wouldn't have time to like mathematically prove that the greedy solution is indeed correct. So during a contest, you can go ahead with it. However, as mentioned, mathematically proving that a greedy solution will be the correct solution can be a bit more challenging. That will involve some math, and so that's a bit more complex. We're not going to go into that for now. But yeah, I hope this you guys will learn something about the greedy approach, especially the importance of coming up with test cases on your own. So yeah, we've come to the end of this session. I thank you all for listening and please fill the feedback form. I'll wait for a minute or so. So I guess all of you have scanned the QR code. So yeah, that marks the end of the first part of the session. So now Advik will be covering brute force, which is another common topic that you'll encounter in your brute forces problems. So yeah, thank you all. I'll stop sharing my screen now.
Hi everyone, I'm Advik. I'll be taking the session for brute force now. Hold on for a minute while I share my screen. Okay then, I'll start. So brute force is in one way like the easiest method you'll think of. It's just testing every single case one by one. So the definition would be to solve the problem by trying every single possible solution until you hit a solution. So it's not a very sophisticated solution. Usually, you will just be trying to just try every single combination or every single number until you find something which can help you get the solution. So it's very simple and straightforward, and usually the first thing you'll think of, and it's applicable in almost every problem because there is usually a way to brute force the answer. Like, say, you need to find a password, you can start testing every single letter from one letter to 1,000 letters and see when you find the correct password, but that will take a very long time. So that's an example of brute forcing. This is one of the earliest problem solving methods because of its simplicity. So now I'll go over to the advantages. So it's very simple to use, very easy to understand. It's the first thing you'll think of, and it guarantees finding the correct solution. So in some algorithms like greedy, which Anton just did, you don't know for sure if you're going to find the correct solution without doing a bit of proving beforehand. But brute force guarantees that you'll always find the correct solution. And it's very useful for small problem sizes. If the problem size is small, you don't need to try any complicated solutions, and brute force will usually work. And it's preferred if the sample size is small. So now, mainly disadvantages. You have to remember that brute force algorithms are usually very time consuming and computationally expensive. This is why a brute force is not something you can use in every single problem, because they will take a very, very long time. Usually, it could go up into years and decades sometimes. Like in my password example, um, brute forcing a normal password in modern day could take billions and billions of years. So it's a very time consuming method. And for most problems, brute forcing is not a very ideal solution because you can usually get a faster method using other techniques. And it's not very practical for large inputs, again, due to inefficiency. So brute force usually will have an exponential time complexity. So that just means that, if it's 10 elements, it might take 10 seconds, but for 100 elements, it might take 1,000 seconds and stuff like that. For 1,000 elements, it might take a million seconds. So yeah, that's the basic run through of brute force. It's a very simple algorithm, and it's not like one use one size fits all. Like, you have to think of the brute force approach. So I'll give some examples. So here, given an array and a target sum m, can you find two numbers which sum up to m in the array? So you have an array of, say, 5 elements, say 1, 2, 3, 4, 5, and you need to find two elements which add up to 7. So you can, think of ways so that you can find two elements such that their sum is 7. So I'll stay here for 30 seconds while you think of answers. Okay, fine. So yeah, I saw an answer in the chat. So yeah, essentially you can make two for loops such that you find two elements and their sum adds up to m. So here there are some things you have to keep in mind, that I am starting from I plus 1 and not 0 again. Can someone say in chat why I'm starting from I plus 1 and not from 0? Yeah, that's also a valid solution to create a copy of the array, subtract elements from M and look for common elements. That is possible. That is a solution. Indices repeat again. Exactly. Yeah. So you don't need to check from zero to the size again, because then you will be checking everything twice, which is not required. So you go, you set the first element. So this first loop kind of sets the first element. So zero till the size. So say now the first element is set. Now you'll check from the second till the last element and check if their sum adds up to m. Or else next one the first element, and then the third no next one will be second element and the third to the last element. So in our 1 2 3 4 5 example for 7, so this would go 1. So 2 3 4 5, none of them add up to 7. Now it will be 2 3 4, both of those don't add up. So 2 plus 3 is not 7, 2 plus 4 is not 7, but 5, 2 plus 5 is 7. So now we have found two elements the uh, such that it's the sum is 7. So can you think of a more efficient solution? This is not in the portions for this lecture, but if I'll just wait for 30 seconds to let you guys think of a smarter solution. um, no, the copy method will not be better in any sense. So it's not, there are some unnecessary steps of you making another list, copying everything. So you're going to take extra memory, which is not really required. But yeah, I saw an answer saying sort and use two pointers. Yeah, that's a good method. You'll get the answer much faster. Yeah, yeah, exactly. Sort and then run last to first and first. Um, yeah, okay, fine. So I'll go on to the next example. So given a number n, check if it is prime. This is a very simple example. Uh, yeah. So if you were doing this by hand, how would you check if, say, a number, how do you know 53 is prime? So again, I'll hold on, look at the chat for a bit. How would you check if a number is prime? Yeah, that is true if it has no other fact. Okay, check from 2 to root n. Why root n? 2 to half of that number, that's also valid. Eratosthenes seal, yes, that's also fine. In a later session, we'll go into that more. Right. Okay, fine. Not exactly. There are all numbers have factors greater than root n. N itself will be a factor of the number. But yeah, I get what you mean. So yeah, that is essentially the brute force solution, where you'll check every number from 2 till n and check if any of those are a factor. If they are a factor, then we are wrong. It's not a prime number. But if they are not a factor, then yeah, we know that we've checked every number from 2 to n, and that none of them are factors. That means it is a prime number. So can you think of a more efficient solution? I will show a Slido. Yeah, here you can scan this link and uh, run. Choose whichever one you feel would be a better algorithm. You can use the Slido code as well if the QR code is not working. Okay, so yeah, lots of people have said only checking till the square root of the number. That is correct. Yeah, that is one way you can go about it, because every single number, when you divide it, there'll be a pair of factors, a smaller one and a larger one, unless it's a square root. So that's the other case. But usually it's a pair of factors. One factor will always be lesser than the square root. One factor will be greater than the square root, and one of them will be both of the square roots. So you can check from 2 till the square root of that number, inclusive of the square root. Then check if any of those divide. Then yeah, you'll know if it's valid. So checking only till half of the number is also valid. That is also a way to improve the algorithm. But it's similar to the square root. So only checking prime numbers is the best case scenario. But to only check prime numbers, you'd have to find all the prime numbers less than the square root of this prime number already we are trying to find. So that'll take a while, and in our case, we don't really need to do that. So this would be also a valid approach, but it would take longer. And now only checking odd numbers. This is also a valid approach. If first you check with 2, check if the number is even. Then after that, you can check only the odd number. So whenever you're doing a brute force approach, remember that there are always ways to improve that brute force algorithm, similar to how we are doing here. So you don't really need to check every single case. So yeah. Uh, if you have any questions, you can ask on this slide, on the chat. All right, I'll go to the one more example. So given a number n, change one digit to make it divisible by 7. Yeah, I'd like for people to try in the chat. What's a brute force algorithm? In simple words, it's an algorithm where you try every single solution and wait until you find one. Only A was not the correct option, just most people chose that. That's why it was green. N plus plus till it is divisible by 7. There is a problem in this approach. Try again, or I'll tell the problem in a couple of minutes for everyone to try. N plus n mod 7. This is also, there is a problem. N mod 7 is equal to 0. That's one case. That's one case, but not like, what if it's not divisible by 7? Say try for a number 9. How would you change one digit of 9 so that it's divisible by 7? Int of n by 7 times 7. Hmm. That is an approach, but say, for example, my number is 11. Uh, can you see a problem with that? Yeah, that that is pretty much the right answer. Yeah, I'll take that. So yeah, you can either add the required number so that it's divisible by 7, or subtract the required number so that it's divisible by 7. And it shouldn't change more than one digit. So exactly as this answer says, vary the last digit. That's right. That is one way to approach it. So here is the code where you check every single digit from 0 to 9, and now n by 10, that gives the rest of the number except the last digit, right? And since this is an integer division, it won't give a decimal. It'll just give, n by 10 without the remainder. So 54 will become 5. So now n by 10, oh, I've missed a times 10 here. So yeah, n by 10 times 10. So now 54 will become 5 times 10, 50 plus I, which will vary from 0 to 9. Mod 7 is equal to 0. Then return again n by 10 times 10 plus I. My bad. So yeah, that's our uh, that's our method here. So 54 would work like this. So 54 by 10, 5. 5 times 10, 50. 50 plus 0 mod 7 is not 0. Okay. 50 plus 1 mod 7, still not 0. 50 plus 2 mod 7, still not 0. 53, no. 54, no. 55, no. 56, yes. And we return 56. So here we have to remember that no matter what, the last digit, if you change, one of them will be divisible by 7 because 7 is less than 10. If 7 was 11, then it would be a different story, right? So yeah, you have to remember about these edge cases. So can someone in chat maybe tell me how I would do it if 7 was if it wasn't 7 and 11 instead? Think of a brute force approach only. You don't need to think too much. Here we are changing only. We're trying to change only one digit. So what would be the logical uh, furthering of that reason? Y plus I, so that we can check every single number from 50 to 59. 7 times int n by 7 plus 1 may not be valid always because it might change more than one digit. Like for 19, it would become 21, which is changing more than one digit. So, yeah. Yeah, I have missed a times 10. My bad. N by 10 times 10 plus I. Two for loops and 10 becomes 100. That's a good approach. Yeah. So if it was 11, that would work, and we'd need to check if there's not. Uh, so that is one approach, but there are some issues with that because we need to change only one digit, right? So yeah, there's no guarantee that only one digit would have been changed. So for 11, the logical way to check this would be first check if the for the last digit. If the last digit doesn't work, check for the second last digit. That I think I'll leave it to you guys as an exercise to do. So yeah, these are some ways to use brute force in different problems. So mainly you would be using brute force in problems with small numbers, not too large numbers, because once the numbers get really large, there's probably a better way to do it than brute force. And sometimes brute force is the only way to do it. So then you're lucky and you just have to, uh, solve it in a brute force way. Yeah. If someone has any questions, you can ask them in the chat right now. Can you explain the case for 11? Yeah, okay, sure. So I'll just again with this loop. So here we are checking the last digit, right? So wait, let me change this. One second. Yeah. So here we are changing the last digit by looping from 0 to 9 and you know dividing by 7, checking if the mod is 0. So now if it was 11, first again we would check the last digit. Yes. And now instead of finding returning -1 if we haven't found something with the last digit, we can check the second last digit. So for checking the second last digit, you would, instead of n 100 times 100 plus I times 10 plus n mod 10. So n mod 10 gives the last digit, I times 10 will give the second last digit, and n by 100 times 100 will give the rest of the number. Divided by 11, check if the remainder is 0. If it is, then we found the number. If it's not, then you return -1. Like that, you can check for every single digit if need be, and yeah, you'll either get an answer or not. So in the worst case, you'll only be checking 10 times the number of digits in the number. So even for a gigantic number, a 50-digit number, maximum you'll only be doing 500 checks, which is not too much. Okay, any more questions? Explain again for 11. Okay, so you understand that this code checks the last digit, right? So now we just have to check the second last digit. So you just have to modify this condition to this n by 100 times 100 will give the number excluding the last two digits. So 5432, 5432, n by 100 would become 54 times 100 would become 5400. Then plus I times 10, which will go from 0, 10, 20, 30 till 90. So 5400 plus that plus the last digit of the number, which you can get by doing n mod 10. So now you have 5400, and then you'll go from 0 to 90, 0, 10, 20, 30 till 90, and then the last digit, which is 2. So you're doing 5402 plus either 0 or 10 or 20 or 30 till 90, checking if those are divisible by 11, like that. Okay. If there are no more questions, I think I'm done with this session. We'll send the attendance link again in chat. So if single number is present, then we can't do anything. See, if you're changing one digit, then if it's a single digit number, either 1 to 9, right? But if you remember, like, you can change the digit before that as well, right? It could become Zero one can become 11, 02 can become 22, like that. The code will still work. So I've sent the attendance link again in chat. If anyone has not marked attendance, you can mark attendance. Yeah, I explained this. For a number greater than 10, we'd have to keep changing digits. So not just the last digit. Try for the second last digit, try for the third last digit, so on. About the discussion for code forces problems, we will send editorial, like a written solution. If it's done, you can leave. Yeah, you can leave if you want. Just try your best for the problems. It's fine if you can't solve all of them. All right, I'll end the meeting, guys. Nice session. Do join CodeCraft if you can.